Good morning, dear student. Today we will discuss about the physical quantities, and in our previous class we discussed about the dimension. Today we will discuss about the conversion unit and error. Now there is a two homework. Anyone can do the homework? Yes or no? Please, quick. Yes or no? Deepan Das, yes, sir. Okay. The homework was the dimension of R. R means resistance. Dimension of R. R means resistance. So, according to the Ohm's law, we know V equals to IR. V equals to IR. So the resistance R equals to V by I. At first we have to know the dimension of V. V means potential difference. Potential difference. We know potential difference equals to W by Q. To bring a unit positive charge from an infinite distance, which amount of work is done, that is called the potential or potential difference. To bring a unit positive charge from an infinite distance, which amount of work is done, that is called potential difference. Amount of work, we know the dimension of work is M. So M L square T inverse 2, because W equals to Fs. M L T inverse 2 is the dimension of F and dimension of S is L, so we can write M L square T inverse 2. Okay, now Q Shoma equal IT. The dimension of I is A and T is T. So Q equals to AT. A is the dimension of I. It's not area. You have to remember this. It's not area. A is the dimension of I. So we can write, from this we can write M A inverse L square T inverse 3. This is the dimension of V. So dimension of B, M A inverse L square T inverse 3. And dimension of I equals to A. So it will be M A inverse 2 L square T inverse 3. So R. So this is the dimension of R. M A inverse 2 L square T inverse 3. Okay. Another homework was the dimension of refractive index. Dimension of refractive index. Refractive index is noted by eta. Is noted eta. So eta means the velocity of light in zero medium and the velocity of light in any other medium. The ratio of the velocity of light in vacuum and the velocity of light in any other medium is called the refractive index. So refractive index, the dimension of refractive index equals to CL T inverse 1, L T inverse 1. So it will be L1 minus 1 T -1 plus 1. So it will be L naught T naught. So eta M naught L naught into T naught. This is the dimension of refractive index. Okay. You can derive the dimension of any quantity in such way. So today, now we will discuss about the conversion of system or unit, conversion of unit from one system to another system. For measurement, we can write conversion of unit, conversion of unit. Okay. For measurement, we know there are three systems. One is CGS, number 2, MKS, number 3, FPS. MKS or SI, because in MKS and SI system, the unit of the quantity are same. So MKS system is called SI system. So now we know any physical quantity PQ, any physical quantity, P means physical, Q means quantity. Any physical quantity equals to N into U. N into U. N is the number, and U is the unit. Number and U is the unit. So we can write N1, suppose 1 meter equals to 100 centimeter. So 1 is the number, meter is the unit, 100 is the number, and centimeter is the unit. If 1 is the N1, unit is the U1, this is the N2, U2. So you have to remember N1, U1 equals to N2, U2. Okay. N1, U1 equals to N2, U2. Now we discuss about the conversion of unit. Now, suppose in Newton, F, force, the unit of force in SI system is 1 Newton. Newton, or we can say 1 Newton. And CGS system, it is dyne. So 1 Newton equals to what? Dyne. 1 Newton equals to what? Dyne. So we can write 1 Newton equals to what then? Now, 1 Newton means 1 kilogram meter per second square. Okay. 1 dyne equals to 1 gram centimeter per second square. But what is the relation between Newton or dyne or kilogram meter per second square equals to gram centimeter per second square? Now, okay, 1 Newton equals to 1 kilogram meter per second square. What dyne or equals to what gram centimeter per second square. Okay. At first you have to write in this way. Then, okay, Newton, this is the force. The dimension of force M L square T inverse 2. T inverse 2. In this case, N1 equals to 1. N1 equals to 1. So M1 equals to kilogram, L1 equals to meter, and T1 equals to S. T1 equals to S. So now we can write U1 equals to U1 equals to M1 L1 T1 inverse 2. T1 inverse 2. Okay. In this case, we do not know the value of M2. Okay. Now M1 equals to gram, L1 equals to centimeter, and T2, M2, L2, T2. T2 equals to second. So U2 equals to M2, L2, T2 inverse 2. Now we know the value of U1, U2, and N1 by using this formula, N1, U1 equals to N2, U2, we can determine the N2. So we know N1, U1 equals to N2, U2. So N2 equals to U1 into N1 by N2. U1 value is 1. So no. Okay. So we can write okay. N2 equals to N1 into U1 by U2. So N1 equals to 1, U1, M1 by M2 power 1 into L1 by L2 power 1 into T1 by T2 power minus 2. Okay. So from this we can write N2 equals to 1 into M1. M1 equals to kilogram. M2 gram power 1 into meter centimeter power 1. Second minus 2 power. So now we can write 1 kilogram 10 to the power 3 gram into gram power 1, 10 square centimeter by centimeter power 1 into 1 inverse 2. Okay. Gram ka centimeter 1 into 10 cube into 10 square into 1. That means 10 to the power 5. So now we know the value NP equals to 10 to the power 5. So 1 Newton equals to 10 to the power 5 dyne or 10 to the power 5 gram centimeter per second square. Okay, understand? We know the gravitational constant G equals to 6.67 into 10 to the power minus 11 Newton meter square kilogram inverse 2 in SI system. In SI system, the value of gravitational constant or universal constant G equals to 6.67 into 10 to the power minus element. What will be the value of G? Value of G in CGS system. What is the value of G in CGS system? That's right. What is the value of G in CGS system? What is the value of G in CGS MK system? CGS system. Okay. At first, you have to know the dimension of G. At first, you have to know the dimension of G. According to the Newton's law of gravitation, we know F equals to G m1 m2 by r square. m1 m2 by r square. G m1 m2 by r square. So we can write G m1 m2 equals to F r square. So G equals to F r square m1 m2. From this equation, we can determine the dimension of G. So dimension of G will be F m L T inverse 2 into L square m into m. So the dimension of G will be m inverse 1 L cube T inverse 2. You have to remember this. This is the dimension of G. M inverse 1 L cube T inverse 2. Okay. This is the dimension of G. Now, 6.67 into 10 to the power minus 11 Newton meter square kilogram inverse 2. So, what is the time centimeter square gram inverse 2? For this, we know the dimension of G is m inverse 1 L cube T inverse 2. Okay. Now here N1 equals to 6.67 into 10 to the power minus 11. And M1 equals to kilogram. L1 equals to meter. And T1 equals to second. Now, U1 equals to M1 inverse 1 L1 cube T1 inverse 2 from this. And N2 equals to what? Okay. Now M2 equals to gram, L2 equals to centimeter, and T2 equals to second. So U2 equals to M2 So M2 inverse M inverse 1, M inverse 1. M2 inverse 1 L2 cube and T2 inverse 2. Now, using this formula, we can determine the N2. We know N1 U1 equals to N2 U2. So N2 equals to N1 into U1 by U2. So N1 6.67 into 10 to the power minus 11. So U1 means M1 M2 inverse 1 into L1 L2 power 3 into T1 T2 inverse 2. Okay. So 6.67 into 10 to the power minus 11 into M1. M1 is the kilogram. And it is the gram. Inverse 1. So L1 is the meter, L2 is the centimeter, power 3. It is second, inverse 2. Okay. Now, N2 will be 6.67 into 10 to the power minus 11 into kilogram equals to 10 to the power 3 gram by gram inverse 1 into 10 square centimeter by centimeter cube into second 1 inverse 2. Okay. Now we can write 6.67 into 10 to the power minus 11 into gram cut. So 10 to the power inverse 3 into 10 to the power 6 into 1. So it will be 6.67 into 10 to the power 14.6. That means minus 8. So the value of N2 is 6.67 into 10 to the power minus 8. So it will be the 6.67 into 10 to the power minus 8 dyne centimeter square gram inverse 2. That will be the conversion of the unit. In such a way, we can convert any quantity in this way. Okay. Now we discuss about some instrument, measurement instrument, which are known to you. Some measurement instruments, suppose as the slide calipers and screw gauge. Slide calipers and screw gauge. Measurement instrument. Okay. At first, we discuss about the slide calipers. It is known to you, and I hope you are a good knowledge about it. So slide calipers, or we can say this is the Vernier calipers. Slide calipers. Slide means, the word slide comes from sliding. It means to movement with touch. Movement of any object with touching, that is called the sliding. Slide calipers. Slide means movement of any object with touch. Calipers means the movement or propagation. So, in a slide calipers, we know there are two scales. One is the Vernier scale, and another is the main scale. Vernier scale and main scale. Main scale is fixed, it does not move. But Vernier scale is moved from one place to another place. On the other hand, we can to and fro. This instrument is invented by Pierre Vernier. So the another name of this instrument is Vernier calipers. Suppose আমাদের চিত্র ঠিক মতো আঁকতে পারি না, মহা সমস্যা আছে। Suppose this is the Vernier calipers and Vernier scale, and this is the main scale. This is called upper jaw. This is called lower jaw. And this is the rod. So the function, there is a function of upper jaw, lower jaw, and rod. We know it. By upper jaw, we can determine any internal diameter of any object, hollow object. Internal diameter of a hollow object. By lower jaw, we can determine the outer radii or outer diameter of an object. And the rod, by using this, we can determine the depth of any object. So this is the function of slide calipers. There is a zero division in a Vernier scale, and there is a zero division in a Vernier scale. If the two jaws, this portion are coincide to each other, if the zero division of main scale and zero division of the Vernier scale coincide to each other, then we can say there is no error in this instrument. Suppose you can consider this is the main scale 0 and this is the Vernier scale 0. They are coincide to each other, so there is no error here. If this is the B and this is the M, if this is the 0 M, the Vernier scale is 0 is here. On the other hand, this is the M and the Vernier scale 0 is here. So the 0 is reading of Vernier scale is to and fro in backward or forward of the zero division of the main scale. Then we can say there is a error is present. This error is called the zero error. This is called the zero error. There are two kinds of zero error. One is the positive error, another is the negative error. If the zero division of Vernier scale is behind the main scale, then that is called the negative error, and that is called the positive error. In forward, that is called the positive error. Now, how can we determine the error and any other measurement? By using slide calipers. Now, for this instrument, you have to at first determine the Vernier constant. Vernier constant. So, what is called the Vernier constant? Vernier constant is noted by VC. Vernier constant is denotes by VC, Vernier constant. Okay. If the two jaws are coincide to each other, two parts of the lower jaws are coincide to each other, then we can say the main scale, zero division of main scale reading and the zero division of the Vernier scale reading coincide to each other. So we consider there is no error here. No error here. So the smallest division of Vernier scale reading and the smallest division of main scale reading are not equal. Why? If the two parts of the Vernier scale are coincide to each other, then we can say the 10 division or 20 division or any other division of the total division of the Vernier scale is not equal to the number of the total division of the main scale. Suppose 10 division of Vernier scale is the 9 division of main scale. 20 division of Vernier scale equals to 19 division of main scale. From this discussion, we can see the smallest division of main scale is greater than the smallest division of Vernier scale. This greater part or smaller part is called the Vernier constant. So we know the main scale are calibrating with centimeter. 0, 1, 2, 3, 4. Between 0 and 1, 10 division are present. So we can say the smallest division of main scale reading is 1 millimeter. The smallest division of main scale reading is 1 millimeter. And so we can say the Vernier constant is the smallest division of main scale reading minus smallest division of Vernier scale reading. Vernier scale reading is called the Vernier constant. Okay, that's all. We discuss about this in our next class. Okay, thank you.